Hello student. So let's solve this question number 3. Four charges of 1 microcoulomb plus 1 microcoulomb minus 1 microcoulomb and plus 1 microcoulomb are placed at the vertices of a square of side root 2 centimeter. So first of all we have a square whose arm is root 2 meter. So this is our square whose arm length is root 2 centimeter, and four charges plus 1 microcoulomb plus 1 minus 1 plus 1 microcoulomb are placed at the vertices of the square in sequence, right? So if we put plus 1 microcoulomb charge here, then we have to put a again plus 1 microcoulomb charge here and a minus 1 microcoulomb charge here and a plus 1 microcoulomb charge here, right? So we have to find what to do. Net force experienced by 0.1 microcoulomb charge at the center of the square. So at the center of the square there is a 0.1 microcoulomb charge, 0.1 microcoulomb charge, and we have to find the net force experienced by this charge 0.1 microcoulomb, right? So here plus 1 microcoulomb, and these four charges will uh, exert force on 0.1 microcoulomb, right? So suppose I name the charges as charge particle 1, charge particle 2, charge particle 3, charge particle 4, right? Consider now the effect of or the force exerted by the charge particle number 2 and 4. See, charge particle 2. This is a plus or positive charge, and here also 0.1 microcoulomb, that is also a positive charge. So this plus 1 microcoulomb will repel it in this direction. Again you see the charge number 4, that is plus 1 microcoulomb, it will also repel in this direction, and the magnitude of the force will same. Why? The value of the force is nothing but k q1 q2 by r square. As the charge number 2 and 4, they are situated at same distance from 0.1 microcoulomb, and the values of the charges are similar or same, and the distance same, so the force of magnitude of the force equal and direction are just opposite, so these two forces will be cancelled out, right? So we have to now consider the force exerted by charge 1 and charge 3, right? So we erase these things to be a clear page. So here we have a 0 point charge, right? Plus 1 microcoulomb, that is charge 1, it will repel 0.1 microcoulomb in this direction, and minus 1 microcoulomb charge, it will attract in this direction, right? So the net force will be in this direction, and the magnitude will be F plus F, that is F net will be 2F. What is F? F is nothing but 1 by 4 pi epsilon naught, right? Q1 q2, that is the charge 1 microcoulomb and 0.1 microcoulomb by what? The distance. What is the distance? Distance is this, right? Distance is this only. Okay, let me choose a different color so that the distance doesn't mix up with another distance. So this is the distance d, right? Here d square. What is the value of the d? D, see, as the arm length is root 2 centimeter, so we need this distance. This is root 2 by 2, this is root 2 by 2, that is 1 by root 2 centimeter, right? And the value of d, 1 by root 2 into root 2 centimeter, that is 1 centimeter. Fine. Okay, 1 centimeter means 10 to the power minus 2 meter, right? We'll calculate it in SI unit or SI method only, because you see the units are in Newton, right? Okay, so 2 1 by 4 pi epsilon naught, the value of this quantity is nothing but 9 into 10 to the power 9. 1 microcoulomb, 0.1 microcoulomb, so I write it as 1 by 10. So here 10 to the power minus 6, here 10 to the power minus 6, I write it as 10 to the power minus 12. Okay, 1 by d square. So d value, the value of d is 10 to the power minus 2 meter, and the value of d square will be what? 10 to the power minus 4 Newton. Okay, so here 9 into 2, that will be 18. Here 10. Okay, now we will work with only the powers of the 10, right? Here 10 to the power 9. In denominator there is 10, so minus 1, and here minus 12 is there, and minus 4 in denominator we have to write it as plus 4, right? So 18 into 10 to the power what? 9 plus 4, 13, minus 13, 10 to the power 0 Newton, that is 18 Newton. So the correct answer becomes option 2.